And welcome back to geology class for another rock lab. I know you're so excited. We're going to start off today with sedimentary rocks. I'm actually going to switch these out. I'm going to start on the detrital side. Let me grab a sedimentary rock identification key. Here we have it. So I will post this on Canvas where you can use it to help you identify the sedimentary rocks. I have two different sheets and you're going to have two different sets of rocks in lab. There will be 10 questions in the lab. But we're going to go over them today and we're going to give you the names of them and let you kind of get an idea of what they look like, what their attributes are. So when you see them in lab, hopefully you can identify them pretty easily. This first sheet, as you can see, is going to be detrital sedimentary. And so the detrital side is made up of rocks that are particularly pieces of other rocks versus the chemical side, which these are sedimentary rocks that come from water. So they come from a solution of dissolved minerals. So different looks to both of these rocks. But we're going to start on the detrital side. So I hope you can see on the left we have grain size. So we're going to start with the very large grain size from coarse gravel. We're going to move our way down to sand and then to our fine silt and mud rocks, which have very small grain sizes. So here are our rocks for today. We have a conglomerate and a breccia. The difference between these two rocks is their pieces inside of them. So you can see the conglomerate is basically a bunch of smaller little pieces of gravel. They're cemented together with some sort of cement. It could be quartz, could be calcite, could be an iron-rich mineral, but they are kind of glued together into one solid rock that's not really going to break apart, but you can see that there's lots of little smaller rocks all on their own inside there. And so just like we talked about in class, a conglomerate is a company that owns several different companies that do different things. This is a rock that has several different types of rocks inside of it that are all joined together to make it one larger rock. So this one is called a conglomerate. Now, in comparison, what we have here is a breccia. This is going to be the same size rock. We go back to the sedimentary rock identification guide. Conglomerate and breccia are right next to each other. They're both gravel-sized grains, but I think you can see from the picture, the conglomerate, everything is rounded, where in the breccia, which kind of sounds like broken, everything is going to be angular. And so it's kind of hard to see in this one. I think there's one side that really shows it better than everything else. Right here, you can really see that these pieces on top are very broken up. Sharp angles, not really rounded like the pieces you see in the conglomerate. There's a little bit of it on this backside. If you look at these tiny pieces in here, nice broken up pieces, nothing really too round, nothing really circular. That is the difference between a conglomerate and a breccia. Both of them are made up of other pieces of rocks. You see a lot of big chunks in here, larger than 2 millimeters. And so they're gravel sized, but one of them is more rounded, which is a conglomerate. The other one is more angular, which is a breccia. Now, moving on. Next down the list is going to be a sand size particles. And this rock, they do have a couple extra ones over here, but in general, if it's a sand size particle, it's going to be called a sandstone. You can add quartz in front of it if you know that it is quartz. But in general, most sand is quartz. So this is your sandstone type rock. It feels rough like sandstone. Usually as soon as you pick up a sandstone, you can kind of tell. You do see a couple layers in here. That's just kind of the way sandstones form. There usually are some visible layers in a sandstone. Although depending on how large your piece is, you may not be able to see them. Because sand will spread out as it gets blown by the wind or moved by the water. It's going to spread out into flat layers and they're just going to pile up. So that's what you're seeing here. Not a lot of interesting things in this, but generally just a medium-sized grain. I don't know if you can hear that, but you can hear my finger kind of rubbing against it. It feels like a piece of sandpaper on the outside. And so this is a sandstone. And moving on, this is your mudstone or shale. You can call it either one. If we go to the chart, they call all of these kind of together mudstone. So it can be a siltstone, a shale, or a clay stone. It really depends on the how fine the particles are. But even with that, it's going to be difficult for you to tell the difference between something that's just over 1/256th of a millimeter and something that's less than 1/256th of a millimeter. So sometimes it's difficult to distinguish between these types of rocks. And so in general, they call them a mudstone. In the same way, any of these rocks up here can just be called a sandstone. So this is your shale. Again, just kind of like the sandstone, you can see some layers in here. Let me get my flashlight on. So you can see a couple lines of layers in here. In the same way that sand is going to spread out when it's moved by the wind or the water, mud will do the same thing, and it will just pile up layer after layer. So usually you can see a couple different layers happening inside of a mudstone or a shale. And so these are our 4 rocks on the detrital side that we're going to go over today. You have your 2 gravel rocks with large pieces. A conglomerate's going to be round. A breccia is going to be broken. Your sandstone, which is medium-sized pieces. And then you have your shale or your mudstone, which is going to be very fine, very small pieces inside. You can't really see any of them individually. But you can see the layers, and the coloring should indicate some sort of mud type or dirt type coloring, although they can be different colors, but definitely not as rough on the sides as the sandstone is. Definitely not a sandy feel to it. So these are the detrital rocks. Now let me switch out my paper. We're going to move over to the chemical side. There are a lot of different types of chemical sedimentary rocks. Essentially, you need to have water. The water needs to dissolve some of your minerals or some other sort of interaction with the minerals. It doesn't always have to be dissolved. And that's going to help create your sedimentary rock. These rocks, by definition, because they're not detrital rocks, are not made of broken up pieces of other rocks. They can be pieces of different things, but not rocks. So we're going to start off first, as you can see, with our crystalline limestone. So if you go over to the chemical sedimentary side, crystalline limestone is going to be on the top. Pretty much anything under this entire branch could be generally called limestone. They do have a couple different types depending on the size, pretty much. So crystalline limestone is going to have fine to coarse crystalline grains of calcite. If it's micrite, it's not going to have any grains. Coquina is basically going to be shells. Do I not have a piece of coquina? I could probably show you that if I have a piece of it. I'm a little surprised that I don't. Let me see real quick. No coquina there. And I don't see any coquina here, so I guess that I don't. I thought I did somewhere, but that must be why it's not on the page. So we're going to start off with our crystalline limestone. As you look at it, you don't really see any large pieces here. It's just kind of like a gray rock. These are pretty boring rocks to look at unless you happen to have some sort of fossils in it. I don't know what this black stuff is on the bottom, but it's more than likely not part of the rock. So just a nondescript, non-uniform gray rock here. No layers usually in these rocks, although I guess it could happen. But in general, these are just a boring gray rock. About the only thing exciting that's going to go on with any kind of limestone is it does have calcite in it. And so, of course, if it has calcite, it can fizz with acid. So let's go ahead and take a look at that. Drip some acid on it. And you definitely get the bubbling and the fizzing going on. I don't have to bring it too close for you to see it. Yeah. So there's your fizzing with acid on your limestone. Anything that has calcite in it, whether it's limestone, marble, any type of limestone, or just calcite itself, will do the fizzing with the acid. So here is your next type of limestone. This is going to be fossiliferous. Looking at this, to be honest, I don't know that you can see a lot of fossils in here. But what you can see are holes, and they're not just regular holes. Like, see that one here? That's a nice flat hole. Here's a flat hole. There's a lot of weirdly shaped things, and you might wonder, why are these holes this strange shape? This isn't like pumice where they're just regular bubble holes that you would expect to see. These holes kind of have a certain orientation, a certain shape. The reason is these holes were created by little shell pieces, little fossil shells that were inside the limestone. In this case, I would imagine the shells have dissolved away, leaving a hole. Sometimes the shells are still in there. You can see them. They'll spiral out, or you'll see a nice piece of a seashell that you would see on the beach. In this case, they've all dissolved away, leaving behind holes. But we know that these holes came from shells because these are not regular little bubble holes. There's something different going on about these. And so this, if you have a decent amount of fossils in your limestone, you're going to call it a fossiliferous limestone. That's going to be the name for it. So these are both made of the exact same thing. When you look at the distinctive properties, they're basically made of shell fragments. This is going to be limestone that has essentially come out of microscopic organisms and settled to the bottom of the ocean. And so in general, both of these rocks are considered deep ocean rocks. So I'm going to drip some acid on this one. You're going to see it bubble away because limestone definitely has a strong reaction with the hydrochloric acid. And so you've confirmed that it has calcite and that it's more than likely a limestone. So moving on, we're going to get away from our limestone rocks. Actually, I guess I do have one more limestone rock. I just put it at the bottom. Down here is chalk. The first thing I noticed when I picked this rock up is it's very light. It has a light color like chalk. I don't know if I should do this on the table, but let's go for it. I did a little bit. You can barely see it on the video. But if I drag this across, it's leaving a line, just like chalk would on a chalkboard. And so this is literally chalk. It's made up of microscopic shell fragments from little tiny microscopic ocean creatures. And they die. Their shells fall to the bottom of the ocean, where they just pile up very thick. And when the rock gets exposed in the rock column, it becomes a chalk. And so this is also going to be a lot of calcite. They use calcium carbonate to build their shells. They pull it out of the water column. If I drip a little bit of acid on here, you can see it just kind of bubbling away. This does have a lot of holes in it. It's porous because of all these little tiny shells. And so it did soak in there. You can see the wet spot's not really going away. So this is chalk. Chalk's usually pretty easy to spot because of its color, a nice white color that looks like chalk, and because it's so soft and it's very light. Definitely not as heavy as the limestone. That's pretty much the same size. So there's your chalk. And then here, hopefully you can see this. This is coal. Coal, as I mentioned in class, is not made up of dinosaur bones. Neither is oil or gas. All hydrocarbons, including coal, including oil and gas, are made up of plant material. They might be from some of the geologic periods that did have dinosaurs roaming around, but this is all plant material. Piles up over and over and over again, gets compressed, gets cooked a little bit, and it ends up as coal. So this is very black. This is bituminous coal, which means it has a high hydrocarbon content in it. So you can see that it's very shiny. Does not look like the manufactured charcoal that you get for your barbecue. This is something that we would use to burn to create electricity or to heat homes. It is a resource type rock. And so coal's usually pretty distinctive as a metamorphic rock because there's nothing on the list other than maybe shale that has this very dark black color. But the shale's not going to be shiny like this. It's going to be a very dull rock. In fact, we can kind of compare them. You can see that the shale is just kind of like a gray, muddy color, where the coal has this nice shininess to it. And so that is it, my friends. These are your 4 rocks on your chemical sedimentary side. You have your crystalline limestone, which is essentially gray rock that has no fossils in it. You have your fossiliferous limestone, which is gray rock that does have fossils in it, or in this case, it has holes where the fossils used to be. You have your black shiny coal, and then you have your white soft chalk, similar to the chalk that we use on the chalkboard. And so these are your 4 rocks on the chemical sedimentary side. We've already covered the 4 rocks on the detrital sedimentary side. This video should help you work through the lab. And if you have any questions or you need any further explanation or you want to see a rock up close or anything, just let me know, send me an email, and I will work something out for you. So thank you for joining me today. I hope it was super exciting for you, and I hope you have a nice day. Thank you.